In this video, I'll be going over the Mock 2 review. So these first few questions have to do with our polynomials. So for the first one, we are using f of x and g of x, but notice how we are going to now subtract g of x minus f of x. So g of x needs to go first. So g of x is here, which is 4x minus 5. Then we're going to subtract from that f of x, and I'm going to write that in standard form. So negative 8x cubed plus 3x plus 2. Then notice, right, when we're subtracting, you need to first distribute that negative 1 here. So here I've got 4x minus 5, then now no longer negative 8x cubed, but positive. So plus 8x cubed minus 3x minus 2. Now we can start combining like terms. There's no other x cubed, so 8x cubed, but I do have 4x minus 3x giving me 1x, so plus x. And then last I have negative 5 minus 2, which is negative 7. Then notice here, we're taking our two functions and now we are multiplying them. So because f of x is 3 terms and g of x is 2 terms, I need to set up a 3 by 2 area model or box method here. Again, I'm going to write it in standard form. So the polynomial, so negative 8x cubed plus 3x plus 2. Then here I've got 4x minus 5. Then we can go ahead and start filling in. So I've got negative 32x to the fourth, because that's 3 x's here times another x. So that's why we have x to the fourth. Now I've got 12, but x squared from x times x. And then here, 4x times 2 is 8x. Now I've got a negative times a negative, making that now a positive 40 and x cubed. 3x times negative 5, negative 15x. And negative 5 times 2, negative 10. Then notice here, like terms, I've got negative 15x plus 8x, which is negative 7x. And we also have, oops, as I started and I realized, we don't have any other like terms to combine. So that's it, as I just started getting into the mode here. So the final answer is negative 32x to the fourth plus 40x cubed plus 12x squared minus 7x minus 10. So notice that the x terms were the only like terms here in this case that you could combine. Question number 3. So you're using the rectangle here for 3 and 4. Now we are just calculating the perimeter of the rectangle, which is adding up all the sides. Remember, rectangles, opposite sides are the same. So if this side here is 7x plus 2, that means the opposite is 7x plus 2. And here, if this side here, the width is 3x squared minus 4, that means the side opposite is also the same, 3x squared minus 4. Now perimeter, you just add up all of the sides. So I'm going to combine like terms here. So I have 3x squared plus 3x squared, which is now 6x squared. Then I've got x, so 7x plus 7x, which is now 14x. Then last, we do have our constant. Negative 4 minus 4 is negative 8. But I also have 2 plus 2, which is 4. So negative 8 plus 4 is negative 4. So that expression is the perimeter of the rectangle. So then if I wanted to find the area of the rectangle, so I'm going to erase this. So to find area of the rectangle, remember area is just length times width. So with the length times the width here, I just need to multiply 7x plus 2 times 3x squared minus 4. I'll go ahead and do box method with this one as well. So our 2 by 2, I've got 3x squared minus 4 and 7x plus 2. So now I've got 21x cubed minus 28x, then 6x squared, and negative 4 times 2, negative 8. Now notice there are no like terms here to combine. We have our x's, but they have different exponents. So the area is 21x cubed plus 6x squared minus 28x minus 8. Then number 5, we're distributing 4x cubed here. So here now I've got 4x cubed times 3x, which is 12, but now x to the 4th, right? Because we're adding our exponents. Then 4x cubed, but now times negative 7. So that's negative 28, but then again, add the exponent. So that's 3 plus 4, making that x to the 7th. Then the next term, 4x squared times 5 is just 20, then x cubed. Then last here, I've got 4x cubed times that negative 2x squared here. So now that's negative 8. Then again, add the exponent. So 2 plus 3 is 5. So writing my answer in standard form, I've got negative 28x to the 7th minus 8x to the 5th plus 12x to the 4th plus 20x cubed. So that's why here that final answer is D. Now number 6, you're calculating the volume of a rectangular prism. Remember, volume is length times width times height. So notice how I'm multiplying 3 dimensions. So I've got my height here, which is x, so h is x. My width, so w, is x minus 5. And my length is 2x plus 3. So these are the 3 dimensions that I need to multiply. So I'll go ahead and do the first 2. So that's just x times x minus 5. And I'm just going to distribute. So x times x squared minus 5x. Now I do need to multiply that now to 2x plus 3. That means now I'll go through and set up my box method. So here I've got my 2 by 2. So x squared minus 5x, then times 2x plus 3. So now I've got 2x cubed minus 10, but x squared from x times x. Now I've got 3x squared and negative 15x. Now here I do have like terms to combine. I have my 2x squared terms here. Negative 10 plus 3 is negative 7x squared. So my final answer polynomial for the volume is 2x cubed minus 7x squared minus 15x. And so now let's get into our factoring and solving. But before we do, there is a typo on the review. So for number 8, the answer choice is not here. So we will have to go through and solve that one like it's an open-ended question. So with number 7, notice how that this is a special case because it's just 2 terms. No x, b is equal to 0. We also have the sum, so we do need I. Then I do have perfect squares because the square root of x squared is just x and the square root of 121 is 11. So factored form is x plus 11i times x minus 11i. Then here, same thing. We have no x and we have the sum. So again, in our factored form, we do need I. Then we need, first off, the GCF. In this case, the GCF here is 12. So I'm going to take out my GCF of 12. And now I've got x squared plus 9. Then notice we still have our sum and we do have a perfect square here. I can take the square root of 9. So this is 12 times x plus 3i times x minus 3i. Then number 9. Now notice we're just subtracting. So it's our 2 terms, no x, right? B is equal to 0, and we're subtracting. So it's the difference. So we don't need I. But there is a GCF. I can factor out a GCF of 2. So taking out 2, now I have 4x squared minus 25. Now notice we do have the difference of 2 perfect squares because the square root of 4 is 2 and the square root of 25 is 5. So don't forget the GCF, but now I have 2x plus the square root of 25, which is 5, times 2x minus 5. Now number 10, we are solving. And then again, this is another special case where we have no x, right? B is equal to 0. So that means we're going to treat it using our square root method. So always add or subtract first. So in this case, we're going to add 294 here to both sides. So when I add 294 here, you do get 6x squared is equal to that 294. Now I can't take the square root yet because x is still being multiplied by 6. So now I need to divide both sides by 6. When you divide by 6, you do get x squared is equal to 49. Now I can take the square root. And here you end up with plus or minus 7. Same thing for number 11. Notice how there is, that's a typo there. Notice how there is no x, right? B is equal to 0. So again, add or subtract first. But I'm going to subtract 72 now because 72 is being added. 3x squared is now equal to negative 72. Now again, we can't take the square root yet because it's being multiplied, x being multiplied by 3. So now divide by 3. And x squared is equal to negative 24. Now we can take the square root. Notice how you're taking the square root of a negative value, so we do need I in our final answer. So it's not B or D. However, we do need to break this apart. So I'll take out that negative 1 here, so that's why we need I. Square root of negative 1 here is I. Then the square root of 24, I can break down to 4 times 6 because the square root of 4 is 2. So 2 radical 6, but because of our I value, that's why the answer is C, plus or minus 2I radical 6. Question number 12. How many solutions does this quadratic have? Remember here, so if I'm looking for is there 2 real, 1 real, we are going to find the discriminant. So b squared minus 4 times a times c. So here's my a, b, and c values. Now I've got b squared, which is negative 8, minus 4 times a, which is 3, times c, which is negative 1. So now here I've got 64 plus 12, which is positive 76. Whenever we had a positive discriminant, we always had 2 real solutions. Question 13. And again, we're solving. However, I do notice now we have 3 terms, but because of our setup of our answers, I'm going to use quadratic formula. So x is equal to negative b plus or minus the square root of our discriminant, b squared minus 4ac, all divided by 2a. I'm going to go ahead and do the discriminant first again. So b squared minus 4 times a times c. Well, our equation's equal to 0, so we're good. So I can identify my a, my b, and my c values. B squared, which is negative 10, minus 4 times a, which is 1, times c, which is 36. Now, when I solve, I have 100 minus 144, giving me a discriminant of negative 44. So because now my discriminant is negative, I have two imaginary solutions. So that means I do need I. But all of them do have I in the final answer. So we're good on that part here. Now I'm going to go ahead and continue solving for x. So I've got negative b, right? So negative b, which is negative 10, plus or minus the square root of our discriminant, which is negative 44, over 2 times a, which is 1. Now notice in the numerator, we do have 2 negatives making a positive. So I have 10 plus or minus. So I do know I need I here. So square root of 44, I could use the square root of 4 times the square root of 11, because again here, the square root of 4 is 2. So we have 2 radical 11, but because of the negative 44, 2i radical 11, all divided by 2. Then now notice here, If you can divide those three values, leave the radical alone, right? And let's divide. So 10 divided by 2 is 5, plus or minus 2 divided by 2 is just 1, so I radical 11. So that's why here the answer was B. Question number 14. We're looking for the solutions. However, we're solving, but it has to equal 0. Because it's equal to 2x, you need to subtract 2x from both sides. So here I've got 3x squared plus 5x. Remember, right? Combining like terms. Minus 12 is equal to 0. Now we can solve. My a is greater than 1. It's 3, so I can't use the table. And I cannot factor out a GCF. All three values do not have a common factor. So bottoms up. Multiply the first to the last. X squared plus 5x, but now minus 36 is equal to 0. Now we can factor. What numbers multiply to get you negative 36 and add to get you positive 5? Positive 9 and negative 4. However, does that mean my answer is negative 9, positive 4? No, because remember with bottoms up, right? Whatever you multiply by, in this case 3, make sure now to divide by 3. Now I've got x plus 3 from 9 divided by 3, bottoms up, so 3x minus 4 is equal to 0. Now we can solve. If it is x plus 3 is equal to 0, then that means x is equal to negative 3. So I can already tell from my test taking strategies that my answer has to be B, because that's the only one that has negative 3. But also notice, remember that little shortcut, I could use the fraction here. So if it was negative 4/3, then I need positive 4/3. So it checks out. Question 15, we are solving. I do notice I need to distribute my x here. So x times x is x squared, and 3 times x is 3x. Still equal to 40, but remember when solving, right, our equation has to equal 0. So that means I need to subtract 40 from both sides, but can I subtract it from anything? No. So x squared plus 3x minus 40. Now here, a is 1, it's just x squared by itself, so we can factor, go straight to the table. What numbers multiply to get you negative 40 and add to get you 3? Positive 8 and negative 5. But because we're solving, right, equal to 0, x is equal to negative 8 and positive 5. Then question number 16 is our last with the solving. I notice I have 3 terms, but noticing too the setup of my answer choices, we do need to use quadratic formula here as well. So I've got negative b plus or minus the square root of, again, the discriminant, b squared minus 4 times a times c, all divided by 2a. Then again here, our quadratic is equal to 0, so we're good. So I can identify my a, b, and c values. So I'll start with the discriminant, b squared minus 4ac. B squared, 2 squared, minus 4 times a, which is 1, times c, which is 5. I've got 2 squared, which is 4, minus 20, giving me a discriminant of negative 16. That means now I have 2 imaginary, so we do need I in our final answer, which again checks out for all of our answer choices. So here we go. So with my fraction, I've got negative b, which is 2, plus or minus the square root of our discriminant, which is negative 16, all divided by 2 times a, which is 1. As I simplify now, I've got negative 2 plus or minus, well, the square root of 16 is 4. The square root of negative 16 is 4i. All divided by 2 times 1, which is 2. Now I can divide everything by 2. Negative 2 divided by 2 is negative 1. Oh, I just realized the typo. Sorry, guys. They were all supposed to say negative 1 here. 1, negative 1, and negative 1. And then plus or minus 4 divided by 2, which is 2i. So negative 1 plus or minus 2i. So that's why here the answer is C. Now we're going to get into our complex number operations. When dividing, remember we have to multiply and focus on the discriminant. I'm sorry, not the discriminant. Oh my goodness gracious, I'm just focusing on quadratic formula here. We need our denominator to be in standard form, but right now it's not. So I'm going to rewrite this as negative 8i over 6 plus 7i. So now I'm going to multiply by the conjugate of the denominator, which is 6 minus 7i. Focus on changing the sign of the imaginary. 6 minus 7i. Now we can solve. We are distributing negative 8i to both terms here. So negative 8i times 6, negative 48i. Then negative 8 times negative 7i, positive 56, but I squared, because that's I times I. And notice I squared is always negative 1. So this isn't positive 56, this is now negative 56 minus 48i over, then here, remember that pattern, right? So I've got 6 times 6, which is 36. We're always going to end up adding, and 7 times 7, which is 49. So when you add 36 plus 49, you do get 85. Then, of course, you can write this also as negative 56 over 85 minus 48 over 85i. Then the next one here, same thing. Notice how, though, our denominator is again not in standard form. So let's rewrite it. 4 minus 5i over 2 minus 3i. So notice how that's a positive 2, then minus 3i. Now let's multiply by the conjugate, which here now we have 2 plus 3i. Change the sign of the imaginary. 2 plus 3i. Now we can solve. Notice how the numerator, though, we are multiplying two complex numbers. So we do need to set up our box here, the area model, to multiply. 4, negative 5i, and 2 and positive 3i. 4 times 2 is 8, negative 10i, 12i, and negative 15, but I squared. Then I squared is always negative 1. So negative times a negative is now a positive 15. So now we have positive 15. I do have my like terms here. 12 minus 10, which is 2i. So now here I've got 8 plus 15, which is 23 plus 2i. Then here we go again. 2 times 2, which is 4, and we're going to always add. And then 3 times 3, which is 9. So 4 plus 9 is 13. Then, of course, we can write this also as 23 over 13 plus 2 over 13i. With our next question here, with our I to that higher power, so remember, right, we always take that exponent, we're going to use the quarter method, and we're going to divide by 4. So when you divide the exponent by 4, you get 60.25. So here we're focusing on the quarters, which 25 is just 1 quarter. So now I can write this as bring down that negative 18 times I, but not to the 241 power, right? Now I to the first power. And I to the first power is I. Negative 18 times I is negative 18i. Notice how we didn't drop the I, so it does stay in our answer. Then here we're multiplying. So remember, when multiplying, don't multiply the exponents, right? Make sure to add the exponent. However, we are multiplying. We have two coefficients, 2 times negative 7, which is negative 14. So we have negative 14i, 3 plus 8 plus 5, which is 16. Then same thing again, we can continue and use our quarter method and divide by 4. Well, 16 divided by 4 is a whole number 4. which is 0.00, meaning you have 0 quarters. So this is negative 14 times I, but not to the 16th power, right? Now I to the 0. And anything to the 0 power is 1. Negative 14 times 1 is just negative 14. So that's why here the answer is A. Then question 21. Notice how in the end we're going to multiply our answer by negative 6. So I'm going to move that out to the side here and remember to multiply by negative 6. Now I do have negative 80 here, which is the square root of 80 times the square root of negative 1. So I know I do need I in my final answer because the square root of negative 1 is I. I could now break 80 apart into 16 times 5 because the square root of 16 is 4. So I've got 4I radical 5. But don't forget, right, we still need to multiply by negative 6. So negative 6 times 4 is negative 24. So negative 24I radical 5. Question 22. Notice this is our special case where we have 5 plus 7I but raised to the second power, which is 5 plus 7I times itself, 5 plus 7I. I'm going to go ahead and set up my box here. So 5 plus 7I times itself, 5 plus 7I. 5 times 5, 25. Then 35I. Then here on the bottom, you have 35I. And now I've got 49, but I squared. Then remember here, I squared is always negative 1. So now positive 49, but times negative 1 is now negative 49. I do also have like terms to combine. That's 35I plus 35I, which is 70I. So now I've got 25, but minus 49, which is negative 21, plus that 70I, which is why the answer here is B. Then 23, we're just multiplying. So again, I'm going to go straight to my box method. And we're going to multiply 8 minus I times 4 plus 3I. Same thing here. I have 32, negative 4I, 24I, and then negative 3, but I squared. Then again, notice here, I squared is negative 1. So a negative times a negative is now a positive 3. Then we do have like terms. We have our two imaginary, 24 minus 4, which is 20, so 20I. Now I can combine 32 plus 3, 35 plus 20I. Now we're combining in question 24. Notice how we're distributing a negative 1. So before I start combining, I'm going to bring down, so 15 minus 11I, but now instead of positive 4, now we have minus 4. And instead of minus 7I, now we have plus 7I. Now we can combine 15 minus 4, which is 11, and then negative 11I plus 7I is now negative 4I. Then our last few questions here. 25, notice before we can start combining, we do need to distribute and multiply 2I here. So 2I times 8 is 16I, and negative 6I times 2I, negative 12I squared. Then I'll just bring down plus 12 minus 15I. I do notice I have I squared, and I squared is always negative 1. Negative times a negative is a positive 12. So 16I plus 12 minus 15I. Now we can combine. 12 plus 12, 24. 16I, but minus 15I is just 1I or I. Then our last question. Notice how we're looking for the value of B here, but I do notice I'm subtracting. So I'm going to first distribute that negative. Make sure to distribute if you're ever subtracting. So I've got 14 plus 4I, but then minus 12 plus BI. is equal to 2 plus 10i. Now we're looking for the value of b. Well, notice b here is imaginary. So on this side here of my equation, I just need to focus on imaginary because that's what b is. What else is imaginary? Well, 4i. So 4i plus bi. No other, because 14 is real and negative 12 is real. We only need imaginary. So this is equal to 10i, because 10 is also imaginary. 2 is real. So 4 plus what gives you 10? That's why here the answer is A,